Hello, and welcome to the Snoozy Scientist. I'm so glad you found your way here tonight. Wherever you are on this beautiful little planet, this gentle space was made just for you. A calm corner where science, curiosity, and stillness come together to put you to sleep. Tonight, we're drifting slowly into one of the most mysterious and fragile relationships in the cosmos, a relationship between Earth and its constant silent companion, the moon. Most nights, we barely notice its presence. It's easy to forget that the moon is even there. It doesn't roar, it doesn't shine like the sun, it doesn't demand our attention. It simply shows up quietly, faithfully, night after night. But what if I told you that this silent companion has been shaping our world in ways we barely notice, but yet depend on every single day? It holds Earth in its arms, balancing its tilt, slowing its spin, stirring its oceans, and guiding its seasons. It's difficult to imagine our world without the moon, but the truth is that it's already leaving us, drifting farther and farther away, little by little, year after year. Tonight, we'll explore what would happen if it vanished completely, what would change in our world, and whether we could ever recover. Before we continue, if you enjoy thoughtful science that helps you fall asleep a little smarter than you were before, it would mean the world to me if you gave this video a gentle like or subscribed if you'd like more sleepy science stories like this. And if you'd be so kind, let me know in the comments, where are you winding down from tonight, and what time is it there? I love watching our little bedtime map light up, one dreamer at a time. So now, take a breath, let your shoulders soften, and let's begin. It's easy to imagine that the moon has always been there, that it rose gently with Earth's first oceans, glowing peacefully in the night sky. But its real beginning couldn't be further from that quiet image. To find the moon's origin, we have to travel back, farther than the first trees, farther than the first fish, even farther than the Earth as we know it. Back to a time when the planets were still new, when the solar system was full of wandering giants, crashing into one another like marbles on a vast invisible table. Earth wasn't calm back then. It was still forming, growing, spinning fast, glowing red hot from the inside out. Its surface boiled with lava. Its skies were thick with toxic gases. There were no blue oceans yet, no clouds, no life, just a violent molten world in motion. And then something came. Another planet, roughly the size of Mars, drifting on a collision course with ours. We call it Theia. We don't know where Theia came from. Some believe it was a sibling planet born in the same region as Earth, slightly off balance. Others think it may have been pulled from a different orbit entirely. But what matters is that one day, about 4.5 billion years ago, Theia and Earth collided. Not a glancing blow, not a soft bump, a full force catastrophic impact that tore both worlds apart. The force of that collision was beyond anything we can truly picture. It shattered Theia, cracked open Earth's outer layers, and sent massive amounts of debris hurtling into space. Molten rock and metal spun outward from the wounded planet, forming a burning halo of Earth's own broken body, glowing with heat, swirling in chaos. For a while, Earth was surrounded by a ring of fire, a spinning disk of vaporized stone and shattered planetary fragments, still glowing from the violence that birthed them. But over time, that disk began to cool. Within it, particles of dust and rock started clinging together, first small, then larger still, drawn together by gravity in a slow spiraling dance. And from that dance, the moon was born, not gently, not peacefully, but forged from chaos. A sphere of rock molded from fire and violence, slowly solidifying as it orbited the ruined Earth. For many thousands of years, The moon was still hot, its surface a sea of molten lava. As it cooled, its crust cracked and hardened, leaving behind the dark, flat plains we now call lunar seas. Even today, when we look at the moon through a telescope, we're seeing the scars of its origin, deep craters, jagged basins, a face forever marked by collisions and trauma. It's a fossil of violence, frozen in space. And yet, despite its brutal beginnings, the moon became something else entirely. Over time, its gravity began to tug gently at Earth. That steady pull slowed Earth's rotation, lengthened our days, and gradually calmed the planet's spin. It helped steady Earth's tilt, preventing wild swings in climate and keeping the seasons on a stable rhythm. This balance was never planned, it was an accident, a random outcome of a disastrous event. But without it, Earth might have remained wild and unstable. Temperatures might have swung violently from one extreme to another. Storms might have raged constantly, and the conditions needed for life, delicate, fragile, and slow to emerge, might never have taken hold. The moon, born from destruction, became Earth's partner in stability. Its constant pull shaped the tides, its calming presence slowed the chaos. It turned a shattered, spinning planet into a world where life could begin. And so, the next time you look up at the moon, soft, silver, and still, try to imagine the fire it came from. Imagine a planet torn apart, molten skies, a ring of glowing rock circling a wounded Earth. Imagine silence, broken only by the soundless pull of gravity, building something new. The moon is not just a light in the sky, it's a survivor, a memory of Earth's earliest trauma, still watching over the world it helped create. And as we move forward in this story, what matters isn't just how the moon was born, but what its presence continues to do to the world we live in. Because though that ancient violence has long since passed, the moon is still shaping Earth every single day. If you've ever stood at the edge of the sea, just before the tide turns, you felt it. The quiet inhale before the ocean begins to rise. The subtle shift in rhythm, a change you don't notice all at once, but feel in your bones. That rhythm, the constant coming and going of the tides, is not just a feature of the ocean, it's a pulse, a heartbeat powered by the moon. As the moon orbits Earth, its gravity gently pulls at the oceans. It's a pulsating Joe and heartbeat Mirrelvire before. It tugs the water toward it, creating a bulge on the side of Earth facing the moon, and because of inertia, a second bulge on the opposite side. As the Earth rotates beneath those bulges, we experience two high tides and two low tides every day. It's a slow, beautiful dance, one that has been going on for billions of years. And without that dance, the oceans would be quiet in all the wrong ways. If the moon were to vanish, the tides wouldn't stop entirely. The sun also pulls on Earth's water, but far more weakly. Without the moon's gravitational influence, tidal ranges would shrink dramatically by as much as 75%. The mighty surges that bring life to the coastlines would become gentle ripples. The vast expanses of exposed mudflats, once home to crabs and worms and burrowing fish, would disappear. The feeding grounds for migratory birds, gone. Without strong tides, the ocean's boundaries would harden. The places where salt water meets fresh water, where marshes breathe in and out with the moon, would stagnate. Estuaries would shrink. Tidal rivers would fall still. Nurseries for countless fish and invertebrates would vanish. Coral reefs, already vulnerable to rising temperatures, depend on tidal motion to bring nutrients, oxygen, and food. Tides wash away waste and bring in the tiny plankton that corals feed on. Without that movement, the reefs would begin to suffocate. Colors would fade. The shimmering cities beneath the waves would crumble. Sea turtles, already few in number, time their nesting with the tides. Without the moon, Their rhythms would falter. Their hatchlings, born under darker, unmoored skies, would struggle to find their way to a quieter, more chaotic sea. And this isn't just about what disappears, it's also about what builds up. Tides are Earth's natural cleaners. They stir the shallow seas. They prevent algae from blooming unchecked. They carry nutrients from the deep ocean to the shore, feeding entire ecosystems. Without those powerful movements, the edges of the sea would become stagnant. Oxygen levels would drop. Dead zones would spread along the coasts. Life that once flourished would now suffocate in silence. But the moon's role goes deeper still, quite literally. Tides don't just affect the surface, they reach into the sea floor, disturbing sediments, moving sandbanks, and shaping the coastline over millennia. This subtle sculpting keeps coastal environments dynamic, ever changing, always renewing. Without those forces, erosion would win, storm surges would bite harder, and the very shape of our continents would begin to shift more dramatically over time. Even the creatures that we can't see, microscopic plankton that drift with the currents, would be affected. They rise and fall with tidal flows, forming the base of the marine food chain. Without those flows, their delicate migration patterns would collapse, and with them the lives of the fish, whales, and seabirds that depend on them. And further out to sea, entire current systems, like the powerful tides beneath ice shelves and fjords, would weaken. These deep, cold currents carry oxygen into the heart of the ocean and regulate temperature across the globe. So, when the moon disappears, it isn't just waves that are lost, it's breath, it's balance, it's the steady stirring of an entire planet's life support system. What's perhaps most haunting is how quietly it would all happen. No crash, no explosion, no obvious destruction, just a slow stilling, a silence creeping in where motion used to be. The sea would still shimmer, it would still reach the shore, but something in its rhythm would be gone. Something ancient, something primal. The tides have whispered with the moon since long before life climbed onto land. Without them, the ocean wouldn't just change, it would feel different, like a song with its chorus missing, like breathing without the rise and fall. And while we might not notice that change at first glance, the creatures who depend on those tides, the birds, the corals, the turtles, the fish, they would know, because for them, the moon doesn't just light the sky, it shapes the world beneath the waves. There's something about Earth that we rarely think about because it's always felt constant, predictable, familiar. The seasons come and go. Spring melts into summer, autumn tumbles into winter. The sun shifts in the sky, but only just enough to let us know time is passing. This balance, this gentle rhythm of heat and cold, of planting and harvest, of migration and hibernation, is something we've always known. But beneath that calm surface, there's a quiet, crucial detail that makes it all possible. Earth is tilted. It spins on an invisible line, an axis, tilted at about 23.5 degrees. That tilt is why we have seasons at all. It's the reason sunlight warms the northern hemisphere in June and the southern hemisphere in December. But what keeps that tilt from wobbling wildly? What stops Earth from tipping too far or standing perfectly straight? The answer is the moon. Like a steady hand resting on a spinning top, the moon helps hold Earth's tilt in place. It doesn't stop the tilt completely. The angle still shifts slightly over thousands of years, but the moon's gravity keeps that movement slow, gentle, and mostly predictable. Without it, though, that invisible balance would vanish. If the moon disappeared, Earth would begin to wobble. Not quickly, not overnight, but over time, centuries, thousands of years, its axis could drift wildly. Sometimes it might straighten almost upright, with little to no tilt. Other times it could fall nearly sideways, tipping over by as much as 85 degrees. Imagine a world where the North Pole could point directly at the sun, where Antarctica might bake under a hot, permanent summer, while the tropics freeze under a bitter, endless night. With no moon to steady it, Earth would spin like a top on a rough table, tipping, shifting, tumbling through cosmic time. And with each shift, the climate would follow. Regions that were once temperate would become frozen wastelands. Rainforests might dry into deserts. Frozen tundras could bloom with wildflowers, only to be swallowed again by ice a few centuries later. The seasons we rely on for farming, for animal migrations, for life itself would become erratic. Spring might come too early one year, too late the next. Some years might see no winter at all. Others might trap entire continents under ice for decades. Human civilizations, which depend on stable weather to grow crops and manage resources, would struggle. Societies built on predictability would be forced to adapt to chaos, but humans wouldn't be the only ones affected. Every living thing on Earth is tuned, in some way, to the rhythm of the seasons. Birds fly thousands of miles, based on light and warmth. Bears sleep through months of cold. Trees bloom and shed their leaves in cycles that stretch back millions of years. All of it, the migration, the hibernation, the blooming, would lose its anchor, and in that confusion, many species would be lost. Even the oceans would shift. Currents rely on temperature gradients created by the tilt of the planet. Without a steady angle, those flows could change direction, slow down, or stop altogether, throwing marine ecosystems into further disarray. Coral reefs, already sensitive to small changes in temperature, could bleach and die as warmth comes when it shouldn't, or fails to come at all. Glaciers would melt and grow unpredictably, raising and lowering sea levels over strange, uneven timescales. Coastlines would vanish and reappear, habitats would be submerged or stranded, and above it all, the skies would change. The sun would rise and set in unfamiliar places. Constellations might shift subtly over time. The ancient navigation stars used by sailors and explorers would drift from their paths, no longer reliable. It's difficult to imagine a world where nothing is in sync, where every season is a question, where nothing, not even the sky, can be trusted to stay still. But that's the world we risk if the moon were to disappear, because its soft silver light isn't just for lighting the night, it's for steadying the day, for holding Earth in a gentle tilt, not too straight, not too far, a delicate angle that has allowed life to root, to stretch, to thrive. And now, as we continue drifting forward, we follow the ripple effects of this quiet collapse, because when the tilt begins to sway, everything else soon follows. We measure our lives in days. Morning follows night. The sun rises, sets, and rises again, and we move through that rhythm, work, rest, wake, sleep, without ever thinking about how fragile that cycle really is. To us, a day is just 24 hours, a fixed unit, a fact of life. But Earth didn't always spin this slowly, and without the moon, it may not continue to do so. Deep in the invisible space between Earth and moon, something quiet and powerful is always happening. The moon pulls on Earth's oceans. We've already felt its gravity in the tides, but those moving tides also pull back. As waves rise and fall, they create drag, not unlike a gentle brake pressing against a wheel. That friction, called tidal friction, slows Earth's spin ever so slightly, year after year. It's subtle, only a fraction of a second lost every century, but over billions of years, it has added up. In the distant past, a day on Earth may have lasted only 5 or 6 hours. The moon, circling much closer then, gradually helped stretch those short, frantic spins into the longer, calmer days we know now. But if the moon were to disappear, that process would stop. Earth would be free to spin faster again, and over time, our 24-hour days would begin to shrink. Not instantly, but steadily. A few thousand years from now, the sun might rise every 20 hours, then 18, then 16, until eventually a full day might last only 8 hours or 6. At first, it might seem like a small change, but faster rotation changes everything. The first to notice would be the winds. As Earth spins more quickly, the atmosphere clings tighter, just like water swirls faster in a tighter turn. Wind currents would strengthen, storms would become more intense, more frequent, more violent. Tornadoes could spin harder, hurricanes could stretch wider, gathering energy from the turbulent seas. Rainfall could shift unpredictably, with dry places getting drier and wet places drowning under sudden floods. Jet streams would speed up. Weather patterns already complicated would grow even more chaotic. But the skies aren't the only thing that would shift. Plants, which follow the sun's light to grow, would need to adapt to quicker changes. Photosynthesis cycles might shorten. Some crops that need long daylight hours to flower or fruit could fail. Animals, too, would be thrown off balance. Countless species, from birds to insects to deep sea creatures, live by internal clocks. They hunt, migrate, sleep, and reproduce based on the rising and setting of the sun. If days became shorter, those patterns would collapse. Nocturnal animals might find their windows for activity shrinking. Day dwellers might be forced to move faster, feed faster, live faster. Over generations, evolution would have to respond, but change is never kind to every species. Some would adapt, others would not, and for humans, with our tightly scheduled world, the adjustment could be deeply unsettling. Imagine waking up every few hours to a new day, the sun rushing through the sky, shadows changing too quickly to follow, night slipping by in a blink, bodies unsure when to rest, when to rise, when to work or eat or dream. Our circadian rhythms, the internal clocks that guide everything from sleep to metabolism, would struggle to keep up. Sleep disorders could become common, mental health might falter, fatigue, confusion, anxiety, all made worse by the simple fact that the days are moving too fast. Entire cities, once built to chase the morning light and dim with dusk, would flicker under artificial skies, trying to compensate. And beneath it all, the Earth itself would begin to bulge at the equator. Faster spinning causes the middle of the planet to push outward, just slightly due to centrifugal force. Mountains might shift, seas could slosh a little higher near the equator and lower at the poles. Gravity, though only changing by fractions, might feel different depending on where you stood. Time itself would feel unstable, not because clocks stopped working, but because we would stop feeling in sync with them. Faster days don't just mean less sunlight, they mean less time for growth, for rest, for all the small silent things life depends on. And just as the moon once helped slow Earth's wild beginnings, its absence would slowly awaken that old chaos again. Even when we don't look for it, the moon looks in on us, through windows, through tree branches, across oceans and deserts and city streets. Its glow slips into our bedrooms, our rituals, our thoughts, quietly shaping how we live and sleep and dream. For most of human history, our nights were guided not by clocks, but by light. And before fire, before lanterns, before the soft hum of screens, there was only one light that truly changed the darkness: the moon. Its phases guided more than just tides. They helped guide us. Ancient humans lived under open skies. The moon's waxing and waning wasn't just beautiful, it was a schedule. It marked time in a world with no calendars. It lit paths for hunters. It signaled when to gather, when to plant, when to move, and it shaped the rhythm of our rest. Even today, Long after we've traded moonlight for glowing phones, something in our biology still listens to it. Studies have shown that human sleep subtly shifts depending on the lunar phase. In the days leading up to a full moon, we tend to fall asleep later and sleep less deeply. It's not just myth, it's measurable. Our ancestors may have stayed more alert on full moon nights, when light made danger easier to see or harder to hide from. Perhaps our brains learned to be more vigilant then, scanning shadows, guarding fire, watching the edges of camp. And though we no longer sleep in caves, those instincts remain buried in us. But what happens when the moon is gone? When the gentle cycle of its phases disappears completely? Our internal clocks, what scientists call circadian rhythms, are built around light and dark. They're not just about sleep, they regulate everything from hormone release to body temperature to digestion. And while the sun is the primary driver of those cycles, the moon plays a quiet supporting role, especially at night when the sun is gone. Without the moon, the night becomes unnaturally dark, constantly dark. The small shift in brightness that came with each lunar phase is gone, and so is the cue it gave us to wind down, to rest more deeply, or to stay alert. Over time, those missing signals add up. Our brains depend on small changes in light to regulate melatonin, the hormone that tells us when to sleep. Without those shifts, the signal gets fuzzy. We might stay awake longer, struggle to fall asleep, or wake up more often without knowing why. And when sleep breaks down, so do other things. Mood begins to slip, anxiety creeps in, focus fades. The mind without rest starts to race or wander. Depression becomes more likely. So do memory problems, appetite changes, and chronic fatigue. Sleep isn't just a recharge, it's repair. And when our biology no longer knows when or how to begin that repair, the damage starts to echo. In children, poor sleep affects growth and learning. In adults, it influences immune health, heart function, and emotional stability. Shift workers who live slightly out of sync with natural light cycles already show higher risks for conditions like insomnia, metabolic disorders, and depression. A world without lunar rhythm would push everyone closer to that state of constant internal mismatch. And beyond the biology, something else is lost too. The moon has long been a companion for dreamers, poets, and those who wander late into the night. Its glow carries symbolism in every culture, for love, for longing, for mystery. Without it, the emotional texture of the night changes. Think of the stories written under moonlight, the songs, the whispered wishes. In its absence, the night becomes flatter, not just darker, but emptier, and in that deeper darkness, human connection shifts as well. There's evidence that even our social behaviors subtly follow lunar rhythms. In some studies, communal activity increases around the full moon. It may be instinctual, a leftover trait from nights when visibility meant safety in numbers. Without that shared glow, gatherings change. The timing of rituals may fade. The pulse of the human experience, already fragile in our modern digital world, becomes harder to synchronize. And as we lose the natural markers that once helped us align with one another, the loneliness deepens. Our bodies know the moon, even if our minds forget. It's not just a piece of rock floating in the sky. It's been a rhythm, a signal, a guide. And without it, the spaces between sleep and wake, between stillness and stress, begin to blur. The next time you lie awake, staring into the night, look for the moon. If it's there, shining quietly above rooftops and trees, know that something ancient is still holding time for you. But if it were to disappear, so would that quiet rhythm, and the night might never feel quite right again. We aren't the only ones who listen to the moon. Long before humans told time by its phases, long before calendars were carved in stone, or rituals timed with the full moon, animals were already watching it, trusting it. They don't name it. They don't understand its science, but they feel it like a whisper in the dark. For millions of species, the moon has been a map, a clock, a signal. Its soft light offers guidance on nights when the world is otherwise pitch black. It tells the coral when to spawn, the crabs when to migrate, the fireflies when to rise, and when it's gone, truly gone, that silence reaches far deeper than we might expect. Some of the first to lose their way would be the ones who always move in darkness. Nocturnal animals, those who hunt, hide, and feed beneath the moon, rely on its glow to shape their lives. But moonlight isn't constant. It waxes and wanes, teaching animals how to adapt to change. Owls, for example, adjust their flight patterns depending on how bright the night is. On full moon nights, they fly higher and more cautiously to avoid being seen by prey. On darker nights, they swoop low and fast, hunting in shadow. If the moon were to disappear completely, those patterns would break. Some would overexpose themselves. Others would stay hidden too long, missing their chance to feed. Sea turtles would suffer almost immediately. When a female turtle climbs ashore to lay her eggs, she chooses beaches based on ancient instinct, many guided by light and lunar tides. And when her hatchlings emerge weeks later, they are drawn toward the brightest horizon, which is usually the ocean, glowing softly under the moon. Without that glow, hatchlings would become lost. Instead of moving toward the sea, they might head inland toward roads, buildings, lights. Many wouldn't make it to the water at all, and the ocean itself would feel the moon's absence. Tiny plankton, some invisible to the naked eye, migrate up and down the water column in sync with the lunar cycle. It's one of the largest daily movements of biomass on the planet. These microscopic creatures form the foundation of the marine food chain, feeding fish, whales, and everything in between. But without the moon's light, their signals become scrambled. Some may rise at the wrong time and be eaten in massive numbers. Others may not rise at all, disrupting the feeding of countless ocean species that depend on them. Birds, too, would lose their way. Many migratory birds use the moon and stars to navigate across vast distances. In the absence of clear lunar cues, their internal compasses begin to falter. Some might veer off course. Others may never leave the safety of the forest, unsure of when or where to go. It's not just navigation that suffers, it's reproduction. Coral reefs, for instance, synchronize mass spawning events with the full moon. Once a year, entire reef systems release eggs and sperm in a synchronized display that looks like an underwater snowfall. It's breathtaking, and it only works if everyone acts at once. Without the moon, those events would fall out of sync. Reproduction would falter. Whole reef ecosystems could begin to collapse from within. Predators would be thrown into confusion as well. Wolves howl more often during certain phases of the moon, not out of mysticism, but because their hunting success is linked to lunar light. Big cats in Africa, like lions, adjust their hunting to take advantage of the moon's darker nights, when prey are less cautious. Without those natural patterns, hunting strategies begin to fail. Some predators would go hungry. Others might overhunt in desperation, driving prey species to the brink. The result would ripple outward, not as one loud extinction, but as a quiet cascade. When one species collapses, others that rely on it begin to fall too. Fewer insects mean fewer bats. Fewer plankton mean fewer fish. Fewer fish mean fewer birds, whales, and seals. In forests, grasslands, oceans, and skies, life would begin to unravel, not because of one great disaster, but because the moon, the soft and silent metronome of the natural world, had stopped playing. It's strange to imagine how something so far away could hold so much influence. But for these creatures, it's not just a light in the sky. It's a rhythm, a pulse, a promise that night doesn't mean chaos, that there is order in the dark. Take that away, and the dark becomes something else entirely. Not just quiet, but disoriented, wild, but broken. As we continue forward, the absence of the moon will begin to touch even deeper parts of Earth's systems. Because in a world where animals lose their rhythm, it's only a matter of time before the Earth itself starts to shake. Some forces are quiet. They don't roar like a volcano or crack like an earthquake. They don't split mountains or send tidal waves crashing into shores. Instead, they pull, softly, steadily, relentlessly. That's what the moon does to the Earth's crust. With every pass in its orbit, the moon's gravity tugs at our planet, not just the oceans, but the solid ground beneath our feet. It's subtle. We don't feel it, but the Earth does. The ground shifts slightly with each lunar cycle, rising and falling by just centimeters, a barely noticeable stretch and release that geologists call Earth tides. This gentle flexing relieves pressure. It helps redistribute strain in the tectonic plates. And though it doesn't cause earthquakes on its own, it nudges the system like a hand adjusting the tension on a tightly wound rope. But if that hand were suddenly removed, if the moon were to vanish, something inside the Earth would change. Without those regular lunar tugs, the delicate balance beneath the crust would start to shift. Pressure that once found small, frequent outlets might begin to build in silence. And when that pressure finally releases, the Earth doesn't whisper, it cracks. Fault lines that once released stress in gentle movements might suddenly give way in more violent jolts. Earthquake patterns could become more erratic, fewer minor tremors, more powerful quakes, unexpected locations. Cities built on the assumption of historical averages might find those averages shifting. Faults long thought dormant could awaken, and places not known for earthquakes might find themselves trembling. But shaking is only part of the story, because under those moving plates lies something even more volatile: magma. Deep within Earth, molten rock swirls and churns in vast chambers. This movement, called mantle convection, helps drive the shifting of the plates above. And here, too, the moon's absence would be felt. Tidal forces, even subtle ones, affect how heat and pressure flow through the mantle. They help stir it, almost like a spoon swirling thick soup. Without the moon's influence, those internal flows could slow in some areas and speed up in others. In certain regions, magma might begin to rise faster, not because of more heat, but because the balance has changed. Volcanoes that once lay quiet could become restless. Magma could find new pathways to the surface or force its way through unexpected cracks. Eruptions that were once rare could grow more frequent, and in some cases more explosive. We might see more volcanic lightning, storms that flash within rising ash clouds, lava rivers rolling over land where nothing has burned for centuries, ash clouds stretching across skies, dimming the sun and cooling the air. And it's not just the land that would be affected. Many of Earth's volcanoes are hidden beneath the ocean, and underwater eruptions, though often unnoticed at the surface, can be even more powerful. They release massive amounts of gas, they change ocean chemistry, and sometimes they trigger landslides beneath the sea, landslides large enough to cause tsunamis. A shift in volcanic activity below the waves could ripple across marine life. It could raise temperatures, kill coral, or release bursts of carbon dioxide and sulfur into the water. Some deep sea vents, home to unique life forms found nowhere else, might disappear. Others might spring up suddenly, reshaping underwater ecosystems that have remained unchanged for thousands of years. And while the volcanoes rage, the very crust of the Earth might begin to look different. The continents float on these plates like rafts, and if the currents below shift, so too might the direction of their drift. It wouldn't be fast, But over millions of years, coastlines would rearrange, mountains might rise in new places, old ones could wear down without renewal. The face of Earth, the one we think of as fixed and eternal, might slowly begin to change, and through it all, there would be no single dramatic moment to blame, just a slow, quiet change in balance triggered by something missing in the sky. The moon's absence would be felt in ways we can't always see, but beneath the soil, beneath the seabed, beneath our very homes, the tension would build, the heat would stir, and Earth, never still to begin with, would start to remember how to move without restraint. Earth has never stood still. Even now, as you sit or lie quietly, the ground beneath you is spinning, not fast enough to notice, but fast enough that every hour sends you hurtling nearly 1,000 miles through space. This motion, our planet's steady rotation, has shaped every moment in human history. It gives us day and night. It controls the length of a heartbeat, the pace of a breath, the rhythm of a life, and the moon has always been there, gently tugging at that spin. Its gravitational pull doesn't just raise tides in the ocean, it also pulls at Earth's motion itself, applying a kind of brake over time. This lunar drag has slowly stretched Earth's days, turning what may have once been a 5-hour spin into the 24-hour rhythm we now call normal. But if the moon were to vanish, that brake would be released. Earth would begin to spin faster. At first, the change would be almost invisible, fractions of a second shaved off each day. But over generations, that spin would accelerate. The days would shrink. Sunrise and sunset would creep closer together. Time, quite literally, would begin to speed up, and the effects wouldn't stop at the clock. Faster rotation stretches the equator outward, ever so slightly, causing the planet to bulge at the middle. Gravity near the poles would feel marginally stronger. At the equator, it would weaken, just a touch. The oceans would respond too. Water would redistribute, not evenly, but with momentum. The equatorial seas would rise slightly, polar waters might fall, wind patterns would shift to keep up with the rotation, jet streams would move faster, storms might grow more severe, swirling tighter and harder in response to the planet's quicker spin. The atmosphere would stretch, distort, adjust. All of these effects, subtle at first, would cascade across the globe. Ecosystems finely tuned to seasonal winds and temperatures would need to adapt quickly or collapse entirely. Migrating birds, ocean currents, and even rainfall patterns could veer off their usual course. But the story doesn't end there, because over long enough timescales, not decades or centuries, but millennia, Earth would begin to feel a different kind of pull. The sun. Even though the sun's gravitational influence on Earth is weaker than the moon's when it comes to tides, it's not nothing. And without the moon acting as the main brake, the solar tides, the gentle gravitational tug from our star, would slowly begin to apply their own drag. Earth, now spinning faster, would once again begin to slow down. But this time, it wouldn't happen with the steadiness the moon once offered. It would be uneven, lopsided, occasionally interrupted by bursts of internal change, volcanic activity, tectonic shifts, asteroid strikes. Instead of a long, slow deceleration like we had with the moon, the planet's spin could become erratic, speeding up, slowing down, shifting unpredictably over vast timescales. And in this strange new rhythm, Earth's climate systems would struggle to keep pace. Longer days would mean longer heating periods, warmer afternoons, hotter deserts. Shorter nights would offer less time to cool, and then as the spin slowed again, the reverse would happen. Some regions might swing from drought to flood, others might see sudden shifts in seasonal length, summers that stretch unexpectedly, winters that arrive too early or not at all. Plants already sensitive to the duration of daylight would bloom too soon or too late. Pollinators could miss their window entirely, leaving crops and wildflowers barren. Even the stars would shift subtly in the sky. Constellations that once marked direction and time would slowly drift off course, no longer lining up with the seasons or the horizon. And though we wouldn't notice these changes from one day to the next, across generations, they would become undeniable. The world would feel less familiar, time would no longer feel as steady, and the idea of a normal day might become something of the past. For a planet that once spun with the soft guidance of a lunar companion, the absence would be felt not as a sudden catastrophe, but as a deep, creeping imbalance. An ancient clock thrown out of rhythm, and as Earth continues this new, unpredictable motion, other forces, ones deeper, more hidden, begin to stir as well. Because when the days begin to twist and the light begins to shift, so too does everything that depends on them. Night, for most of us, is never truly dark. Even on cloudy evenings, even far from city lights, there's usually a soft glow somewhere above us, a pale silver light drifting quietly over rooftops and fields. The moon. Its presence is so familiar we barely register it. A quiet companion, not bright enough to blind us, but just bright enough to keep us company. But imagine a night where it never rises, not just once, but forever. The stars still shine, scattered and distant. The planets still shimmer faintly, if you know where to look. But that gentle wash of moonlight, the thing that turns shadows into silhouettes and fields into silver seas, is gone permanently. Without the moon, night becomes something different, heavier, deeper, not peaceful dark, but absolute dark. And humans have never truly lived in a world like that. For as long as our species has existed, the moon has been there, lighting the path for early hunters, glowing above cave mouths, marking the passage of time with its changing face. We evolved under its light. It shaped our sleep, our stories, our fears. Before fire, before torches, before electricity, the moon was the only thing that pushed back against the night. It gave us just enough vision to move carefully through the darkness, to find shelter, to guard what mattered, to gather in groups and share warmth and food beneath a watchful sky. It's no surprise that some of the earliest calendars were lunar, that so many myths across cultures personified the moon as a goddess, a trickster, a guardian, or a mirror of fate. It was more than light, it was presence. Without it, something inside us changes. When nights become completely dark, not just occasionally, but always, the brain begins to behave differently. There's a reason the moon is so often tied to emotion and intuition. Light, even soft light, gives us a sense of orientation. It defines the boundaries of the world, shows us edges and spaces, gives depth to the night. Take that away, and our perception begins to bend. Our pupils widen, trying to find light that isn't there. But more than that, our brains start reaching, searching the dark for patterns, for meaning, for safety. The fear of the dark isn't childish, it's ancient. It was survival. And without the moon to ease that fear, it deepens. We become more anxious, more cautious, more alone. For people in the past, moonlit nights were often safer, a time for travel, for gathering, for connection. But without any light at all, isolation grows. Communities would retreat earlier into shelter. Even in modern times, outdoor activity would decline. Crime might rise in shadowed cities. Mental health could falter, especially in regions where natural light already struggles to reach. And there's the issue of vision itself. The human eye adjusts beautifully to low light, but not to complete darkness. Our ancestors relied on a mix of moonlight and starlight to hunt and move. Take away the moon, and even with healthy eyes, night becomes a blank page. It would be like being underwater with your eyes open. present but disconnected, a kind of blindness. Over generations, the effects could run deeper. We might begin to rely more and more on artificial light to function at night, but this brings its own problems: disrupted sleep cycles, overstimulation, disconnection from natural rhythms. Our bodies are still tuned to a world where light fades gently, where the moon marks the slow approach of sleep. Without that marker, the boundary between day and night could blur. Sleep might come later or not at all. And while stars are beautiful, they aren't enough to guide us the way the moon once did. They twinkle, but they don't reflect. They shine, but they don't move across the sky in a way that pulls the tides or the blood. The night would become a colder place, not just physically, but emotionally, lonelier, still beautiful, but distant. In that darkness, we might start to remember just how much the moon did, not as a force or a fact, but as a companion. It didn't just light the night, it gave it shape, it gave it company, and without it, even with all our cities and science and satellites, we might find ourselves staring up at the sky and feeling in some small and quiet part of us that something is missing. Long before clocks ticked on our walls, before numbers marked the days, before calendars were hung in kitchens and carved into stone, there was the moon. It was our first timekeeper, our first calendar, our first sense that the world moved in a rhythm greater than ourselves. Every 29 and a half days, it waxed and waned, a perfect, predictable loop, not just light in the sky, but a soft reminder that time was passing. The first humans didn't have numbers for weeks or months, but they had eyes, and they had skies. They saw the moon swell into a glowing circle, then watched it shrink, vanish, and return again. This pattern became their compass in time. Each full moon marked something: a hunt, a harvest, a journey, a birth. It wasn't just a measure, it was a meaning. The moon's phases shaped rituals, told stories, built civilizations. In ancient Egypt, farmers tracked the lunar cycle to predict the flooding of the Nile. In China, entire festivals, like the Mid-Autumn Moon Festival, celebrated the full moon's return. In many indigenous cultures, each full moon had a name tied to the natural world: the wolf moon, the strawberry moon, the snow moon. The Maya used a complex lunar calendar to guide agriculture and ceremony. Islamic months begin with the sighting of a new moon. Even Judaism and Hinduism align sacred days with lunar events. The moon wasn't just a passive sky ornament, it was woven into language, belief, agriculture, and culture. But if the moon were to vanish, that rhythm, the oldest one we've ever followed, would vanish with it. No more crescents to mark the beginning of a cycle, no more full moons to gather under, no more sense of when one month ends and another begins. Not naturally, at least. The lunar calendar, used by nearly every culture at some point in history, would become an orphan system, a relic that no longer aligned with anything visible. Festivals tied to the moon would lose their anchor. How do you celebrate a full moon when the sky holds none? It's not just poetic loss, it's structural. Before mechanical timekeeping, people relied on the moon to organize planting seasons, ritual fasts, and communal gatherings. It brought people together, in sync, under the same sky, watching the same slow arc of light. Its disappearance wouldn't just confuse modern festivals, it would have changed everything in ancient history. Our ancestors built entire temples to trace the moon's movement: stone circles, tower alignments, ceremonial altars that glowed under full moonlight. Stonehenge, Chaco Canyon, the Great Ziggurats, all part of a world where the moon's rhythm shaped not just thought, but architecture. Without the moon, those monuments might never have been built. The need to measure time might have evolved slower. Our awareness of long-term cycles, The idea of months, years, cosmic repetition might have remained scattered and abstract. Even the word month comes from moonth, a direct linguistic gift from lunar timekeeping. Without the moon, language itself may have changed, and in the absence of that glowing returning orb, humans may have turned inward, noticing only the day to day, not the slow arc of time, living by the sun alone, its harsh rise and fall, without the gentle cycle of waxing and waning to soften the edges. The lunar calendar gave time emotion. It made the passage of days feel personal, something you could watch change in the sky, like a silent companion aging with you. Without it, early cultures might have been slower to record history, to organize events, to plan ahead, because the moon didn't just measure time, it taught us that time could be measured. And once we knew that, we could begin to shape our lives around it. But in a sky where the moon no longer rises, that instinct fades, and the rituals that once aligned people across continents, fasting at the new moon, feasting at the full, begin to unravel, not in one sudden moment, but in a slow forgetting, a calendar with no face, a cycle with no sign, a night sky that no longer tells you where you are in time. And as the moon's rhythm disappears, we drift a little further from the stars, and a little further from one another. For most of human history, people have looked to the sky not just for science, but for meaning. The stars, the sun, the planets, they've all been seen as signs, messages, symbols, but none more so than the moon. It wasn't just a light in the dark, it was sacred, a soft, silver witness to our stories, our prayers, and our lives. Its slow rhythm gave structure not only to the passage of time, but to the very soul of culture itself. Across continents, languages, and belief systems, the moon became a thread that tied us to something larger than ourselves. In Islam, the lunar calendar is everything. The months follow the moon, not the sun. Each new moon marks the beginning of a new month. The sighting of the crescent determines the start of Ramadan, the holy month of fasting, prayer, and reflection. And when that month ends, another lunar sighting marks Eid al-Fitr, a celebration shared by millions around the world. Without the moon, these moments would feel unmoored. The rituals once aligned with the heavens would drift, still practiced perhaps, but without the anchor of the sky. In Hinduism, too, the moon plays a sacred role. The lunar phases determine fasting days, festivals, and the auspicious timing of ceremonies. Many Hindu deities are linked with the moon, especially Chandra, the moon god, who rides across the sky in a shining chariot. Buddhists celebrate important holidays, like Vesak, the Buddha's birthday, enlightenment, and passing, based on the lunar calendar. It is believed these events all occurred under a full moon. To meditate beneath that same light is to feel a quiet connection across time. In Judaism, the moon shapes the Hebrew calendar, which is also lunar. Holy days such as Passover and Rosh Hashanah are tethered to its cycles. In pagan and Wiccan traditions, the moon is a goddess in her own right, shifting through maiden, mother, and crone as it waxes and wanes. Rituals are often performed during specific moon phases, drawing on the energy of the cycle for beginnings, endings, healing, and renewal. Even in Christianity, where the sun dominates much of the symbolism, Easter is still calculated using the first full moon after the spring equinox. Buried deep within even the most solar-focused traditions is the moon, but if the moon were to disappear, what would happen to all of this? The rituals would remain, at least at first, but the sky would no longer participate. A Ramadan with no crescent to signal its start, a Vesak with no full moon to sit beneath, a Passover that begins not when the moon is full, but when we say it should. Over time, the link between earth and sky would weaken, Holy days would become less tied to natural rhythms and more tied to human made calendars, and something would be lost. Not the faith, not the story, but the shared experience of watching the same light together. For thousands of years, people have stood under the same moon in different places, speaking different languages, and whispered the same prayers. Lit candles, danced in fields, stood in silence, watched shadows pass across the face of the moon during an eclipse, and felt for just a moment that they were part of something bigger. Without the moon, there would be no more lunar eclipses, no more moments when Earth's shadow paints the moon red, no more wonder at the strange shifting sky, no more harvest festivals under a glowing orb rising over golden fields. The moon has been more than a symbol. It has been a participant in our spiritual lives, a celestial presence that told us when to gather, when to fast, when to rest, when to celebrate. Without it, the rituals remain, but the connection fades. It's like singing a song with no music, performing a dance with no drumbeat, praying to a sky that no longer answers back. Over generations, new systems would replace the old. Electric clocks, digital calendars, precision without poetry. But deep down, something ancient would be missing, because long before we built cities, before we wrote scriptures, or lit incense, or built temples to reach the heavens, we looked up and we saw the moon, and in that soft light we found something sacred. There are few moments in life that silence an entire world. One of them is a total solar eclipse. In those few minutes when the moon glides perfectly between Earth and the sun, everything changes. The temperature drops, birds go quiet, the wind stills, and all around, light fades into a strange silvery twilight. It's not night, it's not day, it's something in between, something rare, something ancient. And then the sun disappears, not behind clouds, not behind mountains, but behind the moon, a perfect fit, edge to edge, as if the moon was placed there on purpose, a dark circle in the sky, and all around it, glowing like a crown of fire, the sun's corona, a halo of plasma stretching millions of kilometers into space. It's breathtaking. It doesn't look real, and for many who see it for the first time, it feels less like astronomy and more like magic. But it isn't magic. It's math. It's coincidence. A fragile cosmic accident. The sun is 400 times wider than the moon, but it also happens to be about 400 times farther away, which means from Earth, they look the same size in the sky. It's that precise balance that makes total solar eclipses possible, and if the moon were to disappear, they would vanish forever. The sun would still shine, its light would still feed the earth, warm the oceans, cast shadows across valleys, but we would never again see it hidden behind a perfect moving circle. There would be no more countdowns, no more eclipse glasses, no more people traveling hundreds of miles to stand in the path of totality, no more sudden stillness as the moon slips into place, no more gasps as the last beat of sunlight, the diamond ring, flickers into shadow, and perhaps most of all, no more corona. The sun's outer atmosphere, usually invisible in the brightness of day, is only revealed when the moon blocks its face. It's during eclipses that scientists have discovered solar flares, studied the corona's strange heat, and mapped the sun's magnetic field. The very word corona, meaning crown, comes from these moments. Moments when the moon acts not as a destroyer of light, but as a spotlight, revealing what lies behind it. Without those eclipses, solar science would have taken longer to unfold. Our understanding of space weather, of radiation storms, of the rhythms of the sun, would have lagged. And beyond the science, there's the wonder. Across cultures and centuries, solar eclipses have been feared, celebrated, studied, and mythologized. In ancient China, They were believed to be dragons devouring the sun. In Norse mythology, wolves chased and swallowed the light. For the Maya, they were celestial messages, omens in the sky. But in every case, they were powerful, because no matter where you stood on earth, no matter what language you spoke, the sudden disappearance of the sun meant something, and now, without the moon, that moment is gone. There would still be partial eclipses, small shadows cast by other bodies, and lunar eclipses would, of course, no longer occur at all. But that heart stopping, all consuming eclipse, when day becomes shadow and the sky forgets its brightness, would become something only the past remembers. It's not just an astronomical event, it's one of the few shared experiences that reminds us how small we are, how beautiful alignment can be, how rare and fleeting perfect balance is. People who witness a total eclipse often describe it as life changing. Some cry, some fall silent, some spend their lives chasing the next one. Because when the sky goes dark in the middle of the day, when the sun becomes a ring of fire and stars blink out over a blue horizon, you feel something words can't quite explain. You feel the scale of the universe. You feel the math of it, the chance of it, the sheer luck that we live in a time when the moon still fits the sun, but the moon is already drifting away, slowly, about 3.8 centimeters every year. Someday, millions of years from now, it will no longer perfectly cover the sun. The era of total eclipses will end, but if the moon vanished suddenly, that age would end today. No more alignment, no more wonder, just sunlight, unbroken and blinding, and a sky that never again forgets how to shine. For all its motion, its spin, its tilt, its tides, Earth is also always falling, not downward, but forward, around the sun. We move in a near perfect loop, an orbit that takes just over 365 days to complete. And though we often imagine this path as a neat circle, it isn't. It's slightly stretched, slightly uneven, an oval, or what scientists call an ellipse. But over thousands and millions of years, that shape can change. The orbit can stretch out more or pull itself closer to a circle. Sometimes Earth swings nearer to the sun, other times it drifts a little farther out, and when those changes happen, they ripple into everything else: climate, weather, ice ages, extinction. These long, slow shifts are called orbital eccentricities, and the moon, quiet as ever, has helped to keep them in check. Like a hand resting gently on Earth's shoulder, the moon has acted as a stabilizer. It doesn't stop Earth from wobbling or stretching its path, but it dampens those extremes. It softens the motion. It keeps Earth from wandering too far off its familiar track. But if the moon were to disappear, that balance would begin to slip. Without its steadying influence, Earth's orbit might slowly become more elliptical, more stretched, more uneven. The gentle path we've followed around the sun for billions of years would grow more erratic, more exaggerated, and the consequences wouldn't be instant. They wouldn't arrive with thunder or flame. They would unfold quietly over centuries, millennia, like the slow turning of a key. Summers would grow hotter. The Earth, swinging closer to the sun at certain points in its orbit, would feel that proximity. Heat waves would intensify, glaciers would melt faster, oceans could expand, swallowing coastlines inch by inch. Then, months later, on the far side of that stretched ellipse, Earth would swing away from the sun, and winters would become colder, not just cold, but punishing. Entire growing seasons might shrink, snow could linger into spring, crops would fail in places that once fed millions. Ecosystems tuned to mild winters could collapse under the sudden weight of frost and silence. This kind of uneven heating and cooling, bouncing between extremes, is something Earth has experienced before. In fact, many past ice ages and warm periods were triggered by small changes in Earth's orbit and tilt. But those changes used to be buffered by the moon, slowed, smoothed. Now, without it, the rhythm becomes more jagged, more unpredictable, less like a song and more like a stutter. And that unpredictability doesn't just affect temperature, rain patterns begin to shift. Some regions that once relied on seasonal monsoons may wait too long for rain that never comes. Others may flood with water all at once, drowning fields instead of nourishing them. Animals, migratory species especially, rely on consistent seasonal cues. A deer in Europe, a caribou in the Arctic, a songbird in the Amazon. They move, breed, nest, and feed based on signals from the land and the sky. If those signals falter, if summer comes too late, or winter never ends, those ancient migrations fall apart. Populations collapse, balance tips, and species begin to vanish, not in flames, but in silence. Even humans, buffered by technology and walls and weather forecasts, would feel the weight of that chaos. Farming would become harder. Entire regions could become too hot to inhabit or too cold to sustain. Water sources fed by melting snowpacks could dry up. Energy grids built for yesterday's weather would strain to keep up. Some years would feel normal, others not at all. And through it all, the earth would keep swinging around the sun, faster in some places, slower in others, in a path that once felt gentle, but now begins to pull and stretch like a thread unraveling. All because one silent presence, the moon, is no longer there to steady the wheel. And as we drift further into this quiet transformation, as the balance of time and space grows more erratic, we begin to see that the moon wasn't just a light in the sky, it was a tether, one that held Earth close, not just to itself, but to the rhythms that made life possible. When we think of Mars, we often imagine a distant desert, quiet, red, empty, a world frozen in time. But Mars isn't just a place we dream of visiting. It might also be a mirror, a warning, because in the grand scheme of the solar system, Mars isn't that different from Earth. It's rocky, it once had water, and billions of years ago, it may have looked much more alive than it does today. But unlike Earth, Mars has no large moon to keep it steady. It has two tiny ones, Phobos and Deimos, both irregularly shaped, like misshapen potatoes. They're too small to cast shadows, too light to shape tides, and too weak to stabilize anything. And without a stabilizing moon, Mars wobbles, not a small wobble, but a wide, dramatic tilt. Earth's axial tilt, the angle at which it leans toward the sun, shifts gently over tens of thousands of years, thanks to the moon's steady pull. But Mars? Mars can swing from nearly upright to almost completely sideways. One moment, its poles are pointed almost straight up. The next, they're tipped toward the sun, cooking the ice caps and plunging the opposite hemisphere into deeper cold. This tilt, called axial obliquity, means Mars doesn't have stable seasons like Earth. Its climate is wild. Its atmosphere, already thin, becomes unstable during extreme tilts. And in those moments of chaos, strange things happen. Massive dust storms rise from the surface, not just in one region, but across the entire planet. They can last for weeks, sometimes months, blocking out the sun, darkening the sky, turning day into a strange, muffled twilight. These storms are so vast they've been seen from Earth. Blankets of dust sweeping across continents, choking the thin air, swallowing solar panels and robotic landers. Imagine standing on the surface of Mars as one of these storms begins. The sky dims, the wind picks up, even though it's barely strong enough to move your suit. Tiny grains of red dust lift off the ground and don't settle for days. It's a place where the seasons don't whisper. They crash, they burn and freeze in cycles no one can predict. And all because the planet is tilting without rhythm, without balance, without a moon. It's hard not to look at Mars and wonder, is this what Earth could become? If our moon vanished, if our tilt began to wander as Mars's does, the consequences would echo across everything. We've already seen how even small orbital changes can trigger ice ages, floods, and extinctions. Now imagine that tilt swinging by 30 degrees or 60. Imagine tropical forests buried in snow, frozen tundras boiling under strange sudden summers, storm systems spinning without familiar boundaries. Like Mars, Earth could begin to drift between climate extremes, never staying stable long enough for life to fully recover. Ecosystems would collapse under the stress, species would vanish before they could adapt, and the weather, something once seasonal, something once expected, would become alien. And unlike Mars, we wouldn't just be observing it from afar, we would be living inside the storm. But it's not just the weather that Mars warns us about, it's the loneliness. Because Mars has no moon to brighten its nights, no silver light to cast shadows across its rust-red deserts, no marker in the sky to guide time or ritual or memory. It turns in silence, its sky stays dark, its surface is still. The dust, once part of ancient rivers, now drifts without purpose, and the planet, though beautiful, feels abandoned, like something that once had a story but lost its narrator. That feeling of isolation, of stillness after chaos, is the final message Mars offers. It's a world that didn't hold on to what Earth still has, the quiet, anchoring presence of a moon. And in that way, Mars doesn't just tell us about itself, it tells us about us, about what we might become if the balance shifts too far, and no one is left to pull it back. High above us, far beyond the clouds and weather, something invisible holds us close. Earth's magnetic field, a vast, unseen shield, stretches out into space, wrapping the planet in a protective bubble. It keeps us safe, safe from the solar wind, a constant stream of charged particles hurled at us by the sun, safe from cosmic radiation that can damage DNA, safe from the slow, silent stripping away of our atmosphere. This magnetic field is made deep within Earth itself. It forms as molten iron swirls around the planet's core, creating electric currents, a geodynamo, like a spinning wire generating energy. It's not steady, it flickers, it shifts, but it works, and quietly over time, the moon has played a role in helping that system stay alive. By slowing Earth's spin, the moon has helped maintain the balance of motion between the inner and outer layers of the planet. That balance is part of what keeps the core churning and the magnetic field strong. But if the moon disappeared, the stability inside Earth could begin to drift. The planet would spin faster at first, as we've already seen, but over time, that change might disrupt the careful engine running beneath our feet. The convection currents in the molten core, so vital to generating magnetism, could begin to slow down. The field could weaken, and the shield could begin to thin. At first, we wouldn't notice. The sky would look the same. The days would feel no different. But far above us, the sun's wind would start to push harder. With a weaker magnetic field, more charged particles from the sun would slip through the cracks. They'd follow magnetic lines down toward the poles and crash into Earth's upper atmosphere. And when they do, something beautiful happens. Auroras, the northern and southern lights, ribbons of green and violet, soft waves of red and blue. They ripple across polar skies, dancing in silence, like brushstrokes made of electricity. These lights are caused by collisions between solar particles and gases high in the atmosphere, mostly oxygen and nitrogen. When they collide, energy is released as light. On a normal day, auroras are rare and localized, seen only near the magnetic poles. But with a weaker shield, those lights could grow. They might stretch farther south, appearing in places that never see them today. Cities like Paris, Tokyo, or New York might suddenly find their skies glowing with color, not once a decade, but once a month, or even more. People would gather to watch, photographers would chase them, poets would write about them. But behind the beauty, there would be risk, because the same particles that make the auroras shimmer can also be dangerous. They can charge the atmosphere, disrupt satellites, damage electrical grids. Airplanes flying at high altitudes might be exposed to increased radiation. Astronauts aboard space stations would face greater threats. And over time, the upper atmosphere could start to erode. Earth, for all its strength, isn't invincible. Our magnetic field is our first line of defense, and it's only there as long as the core keeps turning and the moon's influence remains. Without the moon to help stabilize the inner flow, the long term risk is more than just technical. The very habitability of Earth could shift. A thinner atmosphere means more radiation reaching the surface. Plants and animals sensitive to UV exposure could suffer. Mutation rates in DNA could increase. Coral reefs, already fragile, could bleach more easily. Even human health could be impacted, from skin conditions to cancer risks. And yet, the lights would still come, more vivid, more frequent, more breathtaking than ever. It's strange that something so dangerous could look so beautiful, but that's the story of Earth without the moon, a place where wonder and warning are no longer separate, where the sky glows brighter, but the world beneath it grows more vulnerable. The auroras would dance across the horizon like ancient signals, messages from the sun, painted in color, and somewhere inside, we'd begin to understand that the shield is thinning, and the moon, our silent guardian, is no longer there to help hold it together. Beneath the surface of the world's oceans, something powerful moves in silence. It has no engine, no visible path, and yet it drives the rhythm of our entire planet. These are the global ocean currents, vast, slow rivers of water weaving through the deep, looping across hemispheres, carrying heat, nutrients, and life from one corner of the earth to another. They rise and fall, swirl and sink, not by chance, but by ancient instructions coded into the planet's bones. And the moon, gentle and distant, plays a key part in keeping that code alive. Through its gravitational pull, the moon doesn't just raise tides, it sets into motion a global heartbeat, waves upon waves of water, moving with each tug, each rise and fall. This continuous motion helps power what scientists call thermohaline circulation, a conveyor belt of ocean water driven by differences in temperature and salt. Warm water moves from the equator toward the poles. Cold, salty water sinks and returns deep beneath the surface. This cycle helps regulate the Earth's climate, distributing heat, softening winters, calming summers. But without the moon's steady pull, this entire system begins to slow and possibly collapse. Start in the North Atlantic, home of the Gulf Stream, one of the most powerful ocean currents on Earth. This current carries warm water from the Gulf of Mexico across the Atlantic, warming Western Europe, feeding weather systems, and helping keep entire continents in balance. Without the lunar tides helping push and stir the waters, the Gulf Stream could weaken, or worse, shut down entirely. And if that happens, the changes would ripple out far beyond the sea. Western Europe could plunge into colder, harsher winters, more like Siberia than the soft coastal climates it knows today. Rainfall patterns across the tropics could shift violently, bringing droughts to some places and catastrophic floods to others. Crops might fail where they once thrived. Monsoon seasons could vanish from some regions entirely, leaving millions without water. And in the most chilling possibility of all, Earth could begin slipping into a new ice age. This isn't fantasy. There's evidence that something like this may have happened before. Roughly 12,800 years ago, during the Younger Dryas, Earth experienced a sudden and dramatic cooling. In less than a century, temperatures plummeted, glaciers began advancing again, and scientists believe part of the cause may have been a disruption in ocean circulation, perhaps triggered by melting ice or changes in salinity. If something so subtle could cause something so immense, imagine what would happen if one of the planet's key drivers, the moon, simply disappeared. The ocean wouldn't just fall still, it would lose its rhythm. Without that constant tidal energy to mix layers, stir nutrients, and help guide global flow, the sea could begin to stratify, warm water sitting idle on top, cold water trapped below. Life in the oceans would suffer. Phytoplankton, the tiny plants that feed entire marine ecosystems, depend on upwelling, the process that brings nutrients from the deep to the surface. Without tides, that upwelling slows. Less plankton means fewer fish. Fewer fish means hungry whales, empty nets, collapsing food chains. The loss would rise up the ladder, from ocean to land, from coral reefs to fishing villages, from ecosystems to economies. Coastal cities could face not just ecological breakdown, but economic disaster. Fishermen finding nothing but stillness where once there were shoals, communities built around the bounty of the sea, suddenly empty, silent, and struggling to survive. And then there's the human cost, not just in hunger or hardship, but in the quiet, creeping grief of watching something ancient fade away. For thousands of years, sailors followed currents like roads. Warm water on the wind once told us where storms would form and where the winds would break, but without the moon, the rules of the ocean begin to rewrite themselves. Nothing flows the same. Nothing returns where it once belonged. The ocean becomes unpredictable, not angry, not calm, just lost, and with it, so are we. As we drift further into this quiet unraveling, the disappearance of a force we never thought we needed, the sea reminds us. The moon wasn't just a light in the sky, it was a pulse, one that beat through the water, through the tides, through the heart of life itself, and when it stops, the oceans forget how to move. As the ocean loses its memory of motion and the currents grow quiet, another consequence begins to unfold. Slowly at first, then all at once, the skies begin to whisper of cold, and deep beneath our feet, something ancient starts to stir again, because when the moon disappears, it's not just the tides that go missing, the earth itself begins to lose its balance. We've already felt the first signs, its rotation growing restless, its tilt no longer held steady. That once comforting 23.5-degree angle begins to wobble, not gently, but wildly, like a top losing momentum. This wobble, known as axial precession, may sound like a subtle change, but when paired with the collapse of ocean currents, especially those that once ferried warmth around the planet, the results are anything but subtle. They are brutal. A planet with an unstable tilt and a broken climate engine sets the perfect stage for a new ice age, and not a distant one. This isn't some far off future buried in the next billion years. It's a pattern we've seen before. Throughout Earth's history, ice ages have come and gone, not always in gradual sweeps, but sometimes in sudden jolts, triggered by shifts in orbit, changes in ocean salinity, or minor nudges in solar activity. But without the moon anchoring Earth's motion and stirring the oceans with its tides, those triggers multiply. Suddenly, the planet becomes incredibly sensitive to everything. A slightly dimmer sun, a burst of volcanic ash, an increase in polar snow that reflects more sunlight than it should. Any one of these, on their own, might not have meant much, but now, with no moon, they tip the scale. Glaciers begin to form, at first in the polar regions, where winter snow no longer melts in summer. Then, year after year, the ice spreads outward, creeping across continents. The ice doesn't move quickly, but it doesn't stop either. Forests shrink beneath the growing white, rivers turn to stone, grasslands vanish beneath silent blankets of snow. The landscapes we've known for centuries begin to change, unrecognizably. Tropical zones pull back like frightened animals. Mountain passes vanish under thick sheets of ice. Entire ecosystems shift, trying to follow the warmth, only to find there's nowhere left to run. And while nature is resilient, human life is fragile. Our cities, our crops, our water systems, they weren't built for a frozen earth. Global agriculture, already stressed by unpredictable weather, collapses under the weight of extended cold. Growing seasons shorten to weeks instead of months. Frosts arrive earlier than expected. Crops fail, not in one country, but across continents. Wheat fields, once golden with abundance, remain brown and bare. Rice paddies freeze. Orchards never bloom. And as food dwindles, so does peace. Nations turn inward, hoarding resources. Borders harden. Migration rises as millions flee famine and frost, only to find more of the same elsewhere. It's not just hunger that spreads, it's desperation. And yet, perhaps the most haunting part of it all is the silence. A world in ice becomes a world in hush. The laughter of summer days, the song of birds, the buzz of bees, all fade. Snow falls over once crowded cities. Power lines sag under ice. The hum of life slows to a whisper. And in the dark sky above, no moon, no glow to guide the night, no silver thread to tie us to the heavens. Just the stars, sharp, cold, and distant, and earth once vibrant with motion, now still, locked in a frozen breath. It would not be the first time this has happened. Roughly 700 million years ago, during what scientists call snowball Earth, the planet may have frozen almost entirely, even at the equator. Twice this happened. Life didn't end, but it was pushed to the very edge. Only the most resilient survived, clinging to warm pockets near volcanic vents, hiding beneath ice, holding on through a silence so deep, time itself seemed to pause. And if the moon were to vanish, we may face a version of that silence again. But colder, longer, more widespread, as glaciers scrape across old farmland, as oceans retreat and freeze, as the balance of seasons shatters into unpredictability, we may finally understand just how much warmth the moon once held, not just in its light, but in the way it kept this world in motion. A silent guardian, gone, and in its absence, a cold earth left to wander. Far above the clouds, where the air thins into silence and the sky folds into blackness, another layer of Earth's delicate balance begins to unravel. Satellites, those small silent watchers, drift in their orbits, circling the Earth like beads on invisible strings. They guide our weather predictions, power our GPS signals, transmit news across oceans, and even watch over forests and melting glaciers. They are our eyes in space. But just beyond them, something bigger has always watched over us too. The moon. Quiet and unassuming, it's more than a familiar face in the night sky. It's a cosmic buffer, a protective companion that stands between us and the chaos of deep space. For billions of years, the moon has acted as Earth's shield, intercepting or redirecting wandering debris, asteroids, meteoroids, and space rocks. Many of them never made it to Earth because the moon was in the way. Its cratered surface tells the story. Each scar on the moon's face is one less on our own. But now, imagine that shield is gone. With the moon's absence, Earth becomes more exposed, naked, vulnerable. Nothing stands in the way of space debris anymore, and so one by one, the rules of space begin to change. Tiny objects, pieces of rock no larger than a grapefruit, suddenly become deadly threats. Traveling at tens of thousands of kilometers per hour, Even a speck can obliterate a satellite on impact. A single hit can send thousands of metal fragments spinning wildly, triggering a chain reaction known as Kessler syndrome, a scenario where satellite after satellite is destroyed by debris, creating a cloud of metal shrapnel so dense it becomes almost impossible to launch or operate anything safely in orbit. Our sky becomes a minefield. Satellites begin to fail, some from direct impacts, others from forced evasive maneuvers that sap their fuel and lifespan. Communication delays grow, GPS signals weaken, emergency response systems misfire, ships drift slightly off course, airplanes reroute more often, and the global web that once connected the planet begins to fray. But it isn't just modern satellites that suffer. The moon has also served as a silent landmark, one used for generations of space missions to plan, navigate, and orient themselves. Especially during the early days of space travel, its gravity played a key role in slingshot maneuvers and trajectory corrections. The Apollo missions, for instance, didn't just aim at the moon, they relied on it. Its mass and pull helped guide the spacecraft, and its visibility served as a beacon across the black. Without it, all those calculations become meaningless. The math doesn't work the same. Lunar gravity is gone, and with it, an entire framework collapses. We're forced to rewrite the rules of orbital mechanics. Missions that once used the moon as a stepping stone to Mars, to asteroids, or beyond, must now chart new paths through a more dangerous, more uncertain sky. Fuel requirements increase, travel windows narrow, backup plans shrink, and for space agencies already working on tight margins, this adds a layer of risk that many can't afford. The dream of colonizing the moon? Gone. The idea of mining its surface, studying its geology, learning from its ancient crust, all vanish the moment it does. But even more than the physical loss is the psychological one. For generations, humans looked up and used the moon as a mirror, a symbol of progress, of exploration, of wonder. It was the first destination, the first time we left home, a promise that we could go farther. Now that first step into the universe no longer exists, and as future astronauts gaze into the night sky, training for missions that might never come, they'll see only stars. No familiar crescent to comfort them, no guiding eye to steady their journey. The moon wasn't just a tool, it was a teacher. It taught us how to leave Earth, how to build rockets, how to navigate silence. Its disappearance doesn't just disrupt technology, it disrupts our story, because every satellite we send, every mission we dream, every telescope we launch, all of it began with one simple question: what's that up there? And for millennia, the answer was always the moon. Now, in its absence, we face a space that is colder, darker, and far more dangerous, and Earth, once so sure of its place in the cosmos, must now navigate without its compass. If we go back, far back, beyond pyramids, beyond fire, beyond even language, we arrive at a shoreline, a quiet, ancient coast. The tide rolls in and out with rhythmic grace. The moon, high above, pulls softly at the sea, and in the shallow waters left behind, those warm tidal pools, something stirs. Small, soft-bodied creatures begin to test the edge of the unknown. They do not know they are rewriting the story of life. They only know survival. A wriggle, a push, a moment outside the water, then back again. Over thousands, then millions of years, that first uncertain crawl becomes a bold step. Fins become limbs, gills give way to lungs, and life, once bound to the ocean, begins to colonize the land. But this transformation, the one that would eventually lead to reptiles, mammals, apes, and humans, did not happen in just any place. It happened at the boundary where sea meets land, and that boundary only existed because of tides, and those tides were pulled by the moon. Without the moon, Earth's tides would have been shallow, weak, and almost meaningless. the dramatic flooding and retreat of the ocean, the very thing that exposed creatures to both land and sea, might never have occurred. And so that simple pull from the moon, invisible to the eye, but felt across oceans, may have been one of evolution's most powerful forces. Now imagine it gone. No tides, no pools, no evolutionary pressure to adapt to dry land. The leap from water to land, already so unlikely, becomes even more improbable. And just like that, our entire story teeters on the edge of never beginning. But evolution didn't stop at limbs and lungs. Even long after humans emerged, the moon continued to shape us, quietly but deeply, long before electricity, before campfires, even before language had formed its first full sentence. There was the moon. It lit the path through forests. It kept predators in shadows. It cast silver light on the faces of people huddled together in the night. It gave shape to the dark, and humans, creatures of pattern and rhythm, began to move in harmony with it. We tracked the waxing and waning of its light. We noticed how animals changed with it. We counted time by its phases, and somewhere along the way, we began to dance, to sing, to tell stories under its glow. The full moon became a kind of mirror, not just reflecting sunlight, but reflecting something in us. It allowed for gatherings, for rituals, for the beginnings of belief and belonging. Even communication may have found its footing under moonlight. Facial expressions, so central to human connection, are only useful if you can see them, and for most of early human history, that light came from the moon. No moon, the nights become total, no rituals, no gatherings, no shared myths, just darkness, just fear. And the flickering spark of human culture, the fragile kindling of everything we now know, struggles to ignite. We might still have evolved in some form, but would we have built villages, painted on cave walls, told stories to the stars? Would we have wondered? The moon didn't just shape our biology, it shaped our minds. It helped give us rhythm, structure, memory. It invited us to think beyond ourselves, to gaze upward and ask questions that still have no answers. It was the first calendar, the first light bulb, the first god, the first mystery, and as generations passed, the moon remained, a comfort for mothers rocking babies, a guide for travelers in the night, a silent witness to everything we've become. Its presence was never loud. It asked for no thanks. But behind the scenes, it pulled the strings of our becoming, one tide, one night, one soft silver light at a time. So if you removed it, if it had never been there, would we? And so, without the moon, we may never have come to be. No tides to pull us ashore, no silver glow to gather beneath, no rituals to pass on our stories. But even in a world where humanity still found its shape, one thing would remain certain: the nights would be darker. Not metaphorically, but physically, utterly. Without the moon to reflect sunlight, the world after sunset would become a realm of shadows deeper than we've ever known. The stars alone are not enough to light a path. On clouded nights, the darkness would be near total. In this world of pitch black silence, something primal stirs. Predators. For millions of years, some animals have been fine-tuning their senses for exactly this kind of environment. Owls with eyes that drink in every flicker of light, cats with pupils that open wide like floodgates, snakes that sense the heat of a heartbeat, hiding in the grass, bats navigating by sound alone, darting through invisible maps drawn in echo. To them, the absence of the moon is not a loss, it's a gift. Their advantage sharpens, their reach extends, and slowly they begin to own the night. Small mammals that once scurried under moonlight now stay hidden entirely. The rhythms of prey shift, the forests grow quieter, then more desperate. Each rustle becomes a risk, each scent trail a countdown. The predators aren't evil, they're just efficient, designed for this very moment in Earth's history. But while animals adjust, humans do not fare so well. Our species is not made for the dark. Our eyes falter, our footsteps slow, and our instincts, deep and ancient, begin to tingle with unease. Because even if we no longer live in caves, something inside us remembers when danger lurked just outside the firelight. Without the moon's steady glow to soften the night, human behavior changes. We retreat indoors earlier. Our ancestors, once bold enough to hunt or gather under moonlit skies, now huddle behind closed doors. Fear replaces routine. The outside world feels larger, the unknown closer. And it isn't just nature that begins to turn. Even within the safety of cities, the absence of moonlight touches everything. Electricity might push back the dark in small square windows, but it cannot reach forests, deserts, mountain paths, or rural fields. Those places go silent, they empty out. The night becomes a territory humans no longer claim. And where humans retreat, other forces move in. Without the moon to govern the rhythm of the night, crime patterns may begin to shift. Studies today already show that full moons can reduce certain crimes simply because there's more light and visibility. Take away the moon altogether, and what's left? A perfect cover. A new kind of danger emerges, not just from nature, but from within. Darkness has always been the great concealer, and without moonlight, people begin to disappear into it, both literally and psychologically. Even sleep, once guided by the subtle cues of moonrise and moonset, loses its anchor. Anxiety increases. The imagination, untethered from natural cycles, begins to spiral. We invent myths again, just like our ancestors once did. Only now, the monsters we imagine don't live in the woods. They live at the edge of streetlights, at the fringes of what we think we know. And it's not just fear, it's mystery too, because there's a kind of magic that thrives in darkness. Poets write of longing under moonless skies. Lovers kiss with only starlight to guide them. Stories are whispered by candlelight, made more thrilling by what can't be seen. In a world where night never glows, we may become more superstitious, more secretive, more alone. Children might grow up never knowing the gentle comfort of seeing the moon follow them home. Explorers might lose their celestial compass. Entire cultures might slowly forget what it meant to mark time by a glowing disk in the sky. And even if we rebuild, even if technology steps in to flood the world with artificial light, something irreplaceable is lost. Because moonlight is not just about visibility, it's about presence. It's the quiet reassurance that even in the darkest hours, we are not alone. Without it, the night becomes a place ruled not by reflection, but by shadow, not by guidance, but by instinct. And those who can see in the dark, they win. But in this endless night, where predators thrive and humans retreat, another shift unfolds, one quieter than a howling wind or the rustle of unseen creatures, yet far more powerful in the long run. It begins not with movement, but with light, or rather, the loss of it. The moon, often admired for its silvery glow, does more than light up our skies. It reflects sunlight, not just downward toward Earth's surface, but also upward, outward, into the vast emptiness of space. In this gentle exchange, a portion of the sun's energy is bounced away, never touching our world. This phenomenon, known as albedo, plays a subtle yet vital role in how Earth maintains its temperature. Like a planetary mirror hanging overhead, the moon helps Earth manage the heat it receives. It keeps our planet from overheating, not by a dramatic degree, but by a margin that over time makes all the difference. Now imagine that mirror vanishing. One moment, it's there, gleaming, glowing, catching solar light like a lantern at the edge of a forest. The next, it's gone. The result isn't immediately obvious to the eye. The days still dawn, the sun still rises. But Earth's energy budget, its delicate give and take between incoming sunlight and outgoing heat, starts to shift. Without the moon's reflective surface, less light is redirected back into space. More of it stays, more is absorbed, and slowly, imperceptibly at first, the planet begins to change. The atmosphere warms, not as a single great wave, but as a quiet, creeping tide. Energy that once escaped now lingers. Ocean surfaces retain just a little more heat. The soil stays warmer, longer. The margins that kept everything in balance, cloud cover, air pressure, temperature gradients, start to blur. Even the clouds themselves begin to act differently. Clouds form based on patterns of heat and moisture rising from the Earth's surface. A slight change in energy balance disrupts those patterns. The places where clouds used to gather might dry out. Rain might fall where it never did before, or stop altogether where it was once abundant. Some areas become stormier, others go still. The skies that once followed a rhythm shaped by ancient cycles now begin to improvise. And not all improvisations are kind. Heat waves become longer. Nights without the moon's albedo working in tandem with Earth's own reflection stop offering the same relief. Cities swelter, forests become drier. Ice, already fragile in the face of warming, melts more easily, and as the reflective balance shifts, so too does the balance between life and death in delicate ecosystems. Certain animals and plants rely on temperature cues for migration, mating, and flowering. When those cues blur, so does the choreography of life. Birds arrive before the insects hatch. Flowers bloom without their pollinators. Coral reefs, already threatened by rising temperatures, begin to bleach at an even faster pace. But it's not just nature that begins to falter, it's our understanding of it. For decades, scientists have modeled global warming using simulations that account for every reflective surface on Earth, clouds, ice caps, ocean waves, and yes, the moon. If it were to suddenly disappear, those calculations would falter. The models would need to be rewritten, forecasts would become guesses, projections would lose their footing. Even solar panels, those silent collectors of the sun's energy, would operate differently. Moonlight, faint as it is, still plays a role in nighttime temperature regulation. Remove it, and local climates shift. Crops behave differently. Human behavior adjusts. And it doesn't stop there, because every climate system on Earth, every gust of wind, every ripple of current, every drop of rain, is the result of long-term balances between sunlight, reflection, absorption, and radiation. A missing moon means one less variable we can rely on, and one more unpredictable ripple spreading through everything we thought we knew. It's strange to think that something so distant, so quiet, could hold such sway. But perhaps that's the lesson. Not all guardians make noise. Some protect simply by being present. The moon didn't just light our nights, it helped keep our planet livable, temperate, and responsive to change. Without it, Earth becomes just a little more vulnerable and a little more alone. And still, the sky above remains vast, the stars still burn, the wind still moves across the surface of the world. But the rhythm is different now, and it is in that altered rhythm that we now drift forward toward the deeper cosmic consequences that begin to unfold when one of the most powerful players in Earth's story quietly steps away. As Earth's reflection to space changes and the planet's balance drifts out of tune, it's not just oceans, skies, and satellites that feel the shift. On the surface, in quiet fields and family gardens, something far older and far more intimate begins to unravel. The relationship between humans and the moon didn't start with telescopes. It began in the soil. Long before we charted the heavens, before we understood gravity or orbits, there were farmers, generations of them, watching the skies not for answers, but for timing, for guidance, for signs that only the moon could give. For centuries, perhaps millennia, people have turned to the phases of the moon to decide when to plant, when to prune, when to harvest, and when to rest. In almost every culture that tilled the land, the moon was more than a light in the sky. It was a calendar, a rhythm keeper, a quiet partner in the act of growing life from Earth. Some waited for the full moon to sow seeds that needed light and energy. Others planted root vegetables during the dark phase, when gravity pulled downward and the soil felt more grounded. It wasn't superstition, it was observation, passed down over time, a slow accumulation of wisdom that said, when the moon is here, the earth responds. And in modern times, even as machines replaced hands and chemical formulas replaced folk remedies, this relationship didn't completely vanish. In certain corners of the world, it blossomed into a practice called biodynamic farming, a holistic approach that treats soil, plants, and the cosmos as one connected system. In biodynamic agriculture, the moon's phases still matter. So do its positions in the zodiac and its alignment with other celestial bodies. Preparations are made based on lunar cycles. Compost is stirred under full moons. Even water, carrying memory and energy, moves differently under a waxing or waning sky. To these farmers, the moon isn't a myth. It's a partner. Its light, its pull, its rhythm, all play a role in whether life grows or wilts. Now imagine a world where that rhythm is gone. No waxing crescent, no full moon glowing over the fields, no subtle pull to nudge sap upward or coax seeds awake. The sky becomes darker, not just visually, but spiritually, and the calendar loses something ancient and unspoken. At first, the soil doesn't scream. The seeds still sprout, but the harmony, the feeling that nature and cosmos are dancing together, begins to break. Planting becomes guesswork. Traditional cues vanish. Farmers who once trusted the moonlit night to guide them now find themselves adrift. The earth is still here, but the tempo is lost. Crop yields may begin to shift, not always drastically, but unpredictably. Cycles once fine-tuned by the moon's presence now drift, out of sync with pollinators, rainfall, or seasonal light. And in regions already struggling with climate stress, even small disruptions ripple into food shortages, economic strain, and rising uncertainty. For small farmers, the connection is even more personal. These are not just business decisions, they're ancestral practices. To plant by the moon is to honor tradition, to feel connected to something older than machinery or markets. Without the moon, that connection frays, and something sacred goes silent. But the loss goes even deeper, because in losing the moon's influence on farming, we lose a story, a rhythm that reminded us we were never truly alone in the act of creation, that above every seed planted, there was a silent witness, a silver companion watching over every harvest moon and frost warning, a gentle guardian casting light on toil, growth, and gratitude. Even the rituals, the ones sung quietly at the edge of fields, whispered under breath as soil is turned, begin to fade. Not out of forgetfulness, but out of disconnection. The moon is no longer overhead, and so the stories tied to its phases begin to drift like ash on wind. And yet, the earth still turns, the rain still falls, but the orchestra is missing a violin, the lullaby, a verse, and as the soil rests beneath an empty sky, another part of our ancient relationship with nature disappears, not in flames or fanfare, but in quiet absence. Still, deep beneath the surface, the roots remember. They always have. And from that memory, We now move toward the human spirit itself, how this absence of lunar light and rhythm may echo not just in our fields, but in our art, our dreams, and our sense of cosmic belonging. As the rhythms of farming fall out of sync and the last moonlit harvest fades into memory, the disruption begins to creep somewhere more intimate into the quiet chambers of the human mind and body. Because the moon's pull doesn't stop at tides or soil, it reaches into us, not in ways we always understand, not with certainty or scientific precision, but with a presence that's been whispered about for centuries and felt for just as long. For as long as humans have looked up, we've felt something when the moon is full: a tension, a shift, a glow that feels more than just light. Some studies suggest our moods change ever so slightly during certain lunar phases. Reports of restlessness, heightened emotion, and even aggression have been traced not definitively, but curiously, to the waxing and waning of the moon. In emergency rooms across the world, doctors and nurses have quietly braced for full moons, not because of hard data, but from something deeper, a pattern they've noticed, a kind of collective stirring. And while science remains cautious, some studies finding no solid link, others noting small effects, the feeling persists that somehow, when the moon swells in the sky, so do we. And it isn't just emotion. Human fertility has long been tied to the lunar calendar. The average menstrual cycle, roughly 29.5 days, mirrors the moon's orbit almost perfectly. In ancient times, women tracked their bodies using moon phases, aligning fertility, birth rituals, and even naming traditions to the moon's gentle rhythm. Whether it's coincidence or connection, we evolved under this cycle. Our ancestors lived with it, and even today, the moonlit body clock continues to hum quietly inside us. Now imagine a world where that signal disappears, a world where the moon no longer watches over sleepless nights or newborn cries, where its silver tide no longer rises through us, where full moons vanish from lovers' skies, and the wild moods they once brought slip away into shadow. At first, it may feel like nothing. Life goes on. We still sleep, still feel, still cry. But over time, something begins to change. Without that distant glow, our nights become darker, psychologically as well as physically. The emotional anchor, subtle and ancient, lifts, and slowly a new kind of stillness settles in, not peaceful but hollow. The myths we once told around the moon, the stories that shaped our dreams, our fears, our superstitions, begin to crumble. Werewolves don't howl anymore. The man in the moon has no face. The poetic weight of a lunatic heart grows silent. Even our language, words like lunacy, moonstruck, honeymoon, begin to feel like relics from a world we no longer understand. The subconscious, too, feels the change. For thousands of years, the moon has been a symbol in dreams of mystery, of longing, of cycles and shadows. Artists and writers poured emotion into its shape. Lovers found metaphors in its phases. Parents traced it in bedtime lullabies. But with its disappearance, a blank spot appears, not just in the sky, but in the human imagination. A doorway closed, a dream forgotten, a muse gone quiet. And for some, that silence becomes a weight, because even if the moon's impact on us is more symbolic than biological, even if its pull is less magnetic than emotional, symbols matter. They shape the way we see ourselves. They shape our rituals, our myths, our healing. The moon, in its quiet way, helped us process grief, desire, loneliness, and wonder. It held space for our moods when no one else could. Without it, the night becomes emptier, not just of light, but of meaning, and yet the earth still turns. But it turns through a sky with no phases, through months with no milestones, through seasons without a witness. And in this new lunar silence, the question becomes, who are we without the moon watching us, without its glow, reminding us that change is constant, that darkness gives way to light, that even the coldest nights can carry beauty? As we drift further into this moonless story, the emotional disorientation deepens, and next we begin to see how not only our feelings, but our art, our culture, and our entire creative psyche starts to unravel under skies that no longer shine. As the moon's emotional pull loosens its grip on our minds, something quieter, yet just as haunting, begins to fade from view. It doesn't happen in the sky or in our dreams, but in the depths of the ocean. Far beneath the crashing waves and shifting tides, something ancient and luminous starts to dim, because down there, in the silent blackness of the sea, light doesn't come from the sun, it comes from life. Tiny sparks flicker in the dark, glowing plankton, lanternfish, jellyfish that shimmer like ghosts. Bioluminescence, it's called. Light made by life itself, a chemical miracle. And it isn't random, it dances to a rhythm, a lunar rhythm. For millions of years, countless marine species have timed their glowing displays to the phases of the moon. Some use the moonlight as a backdrop, blinking only when shadows fall. Others wait for the full moon to ignite massive synchronized flashes across the water like underwater fireworks no human ever sees. These are not just beautiful spectacles, they're acts of survival. Bioluminescence helps creatures mate, feed, communicate, and hide. Some flash to attract partners, others to confuse predators, and some pulse light in waves across their bodies like a cloak of stars. But when the moon disappears, so too does the ancient cue that guides these luminous rhythms. No soft glow overhead to signal the start of migration, no full moon to align vast spawning events, no gentle waxing and waning to help creatures count their way through time. At first, the changes are subtle. The oceans still shimmer barely, a few flickers here and there, but the patterns begin to falter. Spawning seasons go out of sync. Fish and plankton begin to blink at the wrong times, or not at all. Mating rituals collapse, predators miss their moment, prey grow more exposed, and slowly the glow begins to vanish. The ocean starts to feel emptier, not in sound or in shape, but in soul, in wonder. For coastal communities, the change becomes heartbreakingly clear. In places like Puerto Rico's Mosquito Bay or the Maldives' glowing shores, where blue waves once lit up the night like rivers of magic, the waters now slosh in darkness. No more neon halos trailing behind swimmers, no more glittering wakes behind boats, just black water lapping quietly, lifelessly. Tourists stop coming, locals mourn a beauty that felt eternal. Children who once played under shimmering tides grow up without ever knowing it was real. But the loss goes deeper than spectacle. Bioluminescent organisms are more than just beautiful, they're essential. Many of them are at the base of the ocean food web, and without lunar cycles to guide their blooming and breeding, the ripple effect spreads. Fish that feed on them dwindle, bigger predators follow. Entire chains of life begin to weaken, not from pollution, not from overfishing, but from the silent loss of the moon's invisible hand. Even researchers feel the void. Bioluminescence has helped scientists study everything from marine navigation to neural circuits. It's helped them track plankton blooms, detect toxins, even light up brain cells in cutting-edge labs. The loss of this natural glow doesn't just dim the ocean, it dims discovery itself. And yet, perhaps the most painful change is something harder to measure: the loss of awe. There's something about a glowing ocean that touches something primal in us, something that says life is mysterious, the universe is strange, and beauty can come from the deepest dark. In ancient times, sailors thought the glow was magic, souls of the departed, spirits of the sea. Today we know the science, but the wonder remains, or it used to, because without the moon, the seas fall dark, not just in light, but in spirit. And as we stare into that blackness, once alive with living starlight, a quiet question begins to surface. What else are we losing in a world where the moon no longer shines? The answer isn't spoken, it floats like a phantom glow toward the next unfolding truth. Because as the oceans grow dimmer, so too does the human imagination. And next we begin to see how art, poetry, and expression suffer in a moonless world. And as the last flickers of ocean light fade into the deep, something quieter begins to settle above us. Not a noise, not a flash, but a feeling, a stillness so vast it presses on your chest. You step outside into what should be a peaceful night. You look up. The stars are still there, scattered like delicate pinpricks across a velvet sky. Orion still hunts. The Big Dipper still pours. The Milky Way still arches across the heavens like a frozen river of time. But something is wrong. Something is missing. There's no soft curve on the horizon, no glowing crescent peeking above the treetops, no gentle silver light turning rooftops blue or tracing the edge of clouds in delicate halos. No moon, and with it, something else vanishes, something harder to name, because the stars, for all their beauty, are distant. They twinkle like memories of things too far to reach. But the moon felt close. It was ours, a neighbor, a witness, a friend. For thousands of nights it had risen beside us, sometimes shy, sometimes bold. It followed us through heartbreak and celebration, through long drives and campfires, through lullabies whispered into cribs. It watched over lovers, poets, wanderers, and the sleepless, a shared companion across time zones and continents. Now it's gone, and the sky, though still full of stars, feels hollow. Children point upward and ask, why is the moon hiding? Parents search for words that can explain a sky that suddenly feels colder, more indifferent, less human. Even the most hardened stargazers notice it, the silence in the dark, the absence of that familiar pull, as if a heartbeat has stopped, as if the sky itself has forgotten a line in its ancient song, and for artists it becomes a silence too vast to fill. No more brushstrokes tracing moonlight over calm water, no more songs about moonlit nights, no more lines of poetry written under its gaze. Across centuries, the moon had been more than a celestial object. It had been muse, metaphor, mirror, a silent partner in the act of dreaming. Without it, creativity feels like trying to sing without melody. Something essential has slipped away. Photographers who once captured the moon rising over city skylines now find only empty frames. Painters stare at blank canvases where moonscapes once bloomed. Poets turn pages, searching for words that feel anchored to anything real. And then there's the emotion, the part you can't draw or write or photograph. The feeling you get when you see the moon low on the horizon, impossibly large and golden, rising like a secret behind the trees. That tug in your chest, that quiet hush of wonder. Now it's just dark. Nights seem longer somehow, not in hours, but in mood, a kind of loneliness that settles in around your shoulders, as if the earth itself is grieving, as if every night it looks over its shoulder, searching for the companion that once danced around it so faithfully, and finds only shadow. The tides, the winds, the sky, they've all changed, but this is different. This is emotional, spiritual, intimate. It's the ache of absence, the kind of loss you don't notice all at once, but feel in small moments, like when you catch yourself glancing up and expecting to see a glow that isn't there, a habit you didn't know you had until it's broken. And for those who live by the sea or the forest or under big wide open skies, the change is suffocating. Walks at night feel less safe, less magical, less inspired. Even romance wilts a little in the dark because the moon wasn't just light, it was a presence, a mood, a rhythm. Its silence had weight, and now that silence is gone. What's left is a sky that looks the same to the eyes, but feels different to the soul. And as Earth quietly turns, no longer illuminated by that faithful mirror in the sky, we begin to understand some losses can't be measured in science alone, because even though the stars are still there and the constellations still shine, the night feels emptier, colder, and the world just a little more alone. But even in that deepening darkness, something else still moves above us, something not lost but altered, because now, with the moon gone, shadows change, light behaves differently. And as we begin to notice these strange new textures in the darkness, long before we ever launched satellites or built space stations, humans were already looking up at the moon, wondering it was the first celestial body we ever tried to understand, the first we ever mapped with our eyes alone, the first that made us feel small but also curious. In every ancient culture, the moon was more than just light in the darkness. It was a symbol, a presence, a destination. Poets imagined walking on it long before scientists did. And when we finally gained the tools to reach for space, the moon was our first true target, the closest stepping stone in an ocean of stars. But without the moon, none of that would have happened. No craters to wonder about, no waxing and waning cycle to track, no lunar eclipses to study, no reason to even imagine a journey there. The great age of space exploration as we know it would look very different, because the moon wasn't just the inspiration, it was the perfect proving ground. In the 1960s, it became a silent witness to one of the most profound moments in human history. For thousands of years, we had only dreamed about visiting another world. But on July 20th, 1969, a human being, Neil Armstrong, stepped down onto the dusty gray surface and changed everything. A small step for man, he said, a giant leap for mankind. And yet, that leap only happened because the moon was there. It was close enough to reach without needing impossible technology. Its gravity was weak enough to escape, but strong enough to practice landing. It had no atmosphere, which meant no weather to interfere, no storms to wait out. And unlike the distant planets or the deadly radiation belts of space, the moon was patient, predictable, quiet, waiting. The Apollo missions weren't just about flags and footprints, they were laboratories. They taught us how to design life support systems, how to navigate beyond Earth's magnetic field, how to engineer rockets powerful enough to escape the gravity well we were born into. Without the moon, we wouldn't have learned how to survive in space. We wouldn't have discovered lunar rocks that rewrote the story of Earth's own formation. We wouldn't have sent robotic landers or orbiters to test deep space communication. We wouldn't have trained astronauts to operate in one-sixth gravity. And we might never have built the confidence or the political will to pursue Mars, Europa, or anywhere else beyond the sky. Without the moon, our imagination might have been grounded permanently. Even now, the legacy of lunar missions echoes through everything we do in space. GPS systems, satellite telemetry, planetary imaging, they all benefited from the experiments, the engineering, the breakthroughs that began with lunar exploration. When we gaze at images from the James Webb Space Telescope, when we monitor the weather from geostationary satellites, when astronauts float aboard the International Space Station, the silent truth is that none of these steps would have been taken if the moon had not quietly drawn us forward, closer, and then outward, because there is something deeply human about needing a nearby horizon, something we can almost touch, something to aim for first before we try to fly too far. The moon was that first horizon. It taught us how to aim higher, but gently, realistically, step by step. And had it never existed, there's a chilling possibility we may have never gone anywhere at all. There would be no lunar dust sealed inside glass displays, no footprint pressed into alien soil, no mission control rooms erupting in tears and applause, no Earthrise photo, that fragile blue marble hanging above the lunar plane, which helped awaken an entire generation to the beauty and vulnerability of our home, and no shared memory etched into human consciousness of the night we truly left Earth for the very first time. The moon made us explorers, not just in the physical sense, but emotionally, spiritually, philosophically. It reminded us that we are capable of more, that distance is not a barrier, that the unknown isn't something to fear, but to reach toward with steady hands and a trembling heart. Without it, the sky might still be full of stars, but our eyes might never have dared to look past them. Across rugged coastlines and quiet inlets, humans once watched the ocean breathe. Tides surged in, then slid away again like the slow rhythm of the planet's pulse. For centuries, they were just a feature of life, a natural clock to fish by, to farm by, to live by. But in the modern world, we saw in them something more, not just movement, but power. Tidal energy, a gift born from the moon's distant pull, became one of the cleanest, most predictable forms of renewable power on Earth. Unlike solar, it didn't rely on clear skies. Unlike wind, it wasn't at the mercy of gusts and lulls. Twice a day, without fail, the ocean moved, and we began to build machines to catch its motion. Huge underwater turbines, anchored to the seafloor, spun as the tides shifted direction. Generators tucked into narrow estuaries captured the rush of rising water. Entire coastal cities started dreaming of a future powered not by smoke and fire, but by the sea itself, quietly, endlessly. And yet all of it depended on the moon. The moon's gravity is what draws Earth's oceans into their daily dance. Its invisible hand lifts and lowers the waters, tugging them toward the sky, then letting them fall. This gentle, cosmic tug of war has powered tidal currents for billions of years, but without the moon, that rhythm would fade into stillness. If the moon suddenly vanished, the tides wouldn't stop entirely. The sun, too, exerts a gravitational pull on Earth's oceans. But the difference would be stark. Tidal ranges would shrink by up to 75%. In many places, the difference between high and low tide would become barely noticeable. The surges that once fed underwater turbines and estuary generators would weaken to a whisper, and the infrastructure built to harness them, often complex, expensive, and coastal, would become useless almost overnight. Imagine the silence beneath the sea, no more groaning turbines slowly turning in rhythm with the tide. No more cities quietly balancing their grids with predictable tidal flow. No more plans to scale up this ancient energy source into the future, a form of power that once seemed eternal, as steady as the moon itself, would vanish along with it, and in its place, a growing void. Communities that once relied on tidal energy to support their local grids would be forced to look elsewhere. Some might fall back on wind or solar if the geography allowed, but not everyone has that luxury. Coastal towns with aging grids might face blackouts. Regions that once took pride in their clean energy profile could be forced to pivot back to coal, gas, or oil, at least temporarily. That return to fossil fuels wouldn't just be a technological step backward, it would carry emotional weight. It would feel like a surrender, a quiet defeat in humanity's long effort to live more gently on the earth. And with fossil fuel use comes everything we've been trying to escape: more carbon in the atmosphere, more pressure on ecosystems, more acceleration of climate change. all because the moon, silent, silver, seemingly distant, was doing more than we ever gave it credit for. The loss of tidal energy would also echo through policy and investment. Ambitious clean energy projects might be abandoned or delayed. Funding once promised for green coastal infrastructure might be redirected elsewhere. Engineers who spent their lives designing tidal systems would be left with outdated expertise, and young dreamers hoping to work with ocean energy might have to look skyward instead, towards satellites or solar panels. But even those alternatives in a moonless world may face unexpected complications. Because the moon didn't just move the water, it helped stabilize so much of Earth's behavior, including the very conditions that made engineering predictable in the first place. Storm patterns could grow wilder, sea levels could shift, and the coastline itself, once a steady frontier, might begin to change in unpredictable ways. What was once a promising frontier for clean energy could become a place of uncertainty, and in that uncertainty, there would be a kind of mourning, not just for the energy we lost, but for the rhythm we once trusted, for the feeling that twice a day the earth took a breath and let it go. In the beginning, the absence would feel unbearable. The rhythms that once stitched time together, the tides, the light, the cycle of darkness and glow, would fall silent. Migrations would fail, habitats would collapse. Creatures that had lived for millions of years, sculpted gently by the moon's pull, would vanish in silence. But Earth does not grieve forever, it adjusts. At first, chaos spreads across ecosystems. Entire food chains shudder and break. Sea turtles, once guided by the glint of moonlight on waves, now hatch into a darkness they cannot understand. Coral reefs, stripped of tidal flushing, grow sickly and pale. In forests, birds that once sang under lunar glow go quiet. But evolution is a slow sculptor. Some creatures begin to change. Eyes that once relied on a faint silver wash grow more sensitive to starlight. Some marine species begin syncing their life cycles to new cues: temperature, pressure, magnetism, anything reliable in this new world without a moon. Insects adapt first, then the fish. Over generations, animals shift their patterns of movement, breeding, and survival. Tiny mutations become meaningful. Entire species reshape themselves to fit the new environment, just as they once did when the first ice ages came and when they left. On land, mammals begin adjusting their internal clocks, no longer tied to the waxing and waning light in the sky. Their sleep becomes fragmented. Some species evolve to rest in shorter, polyphasic bursts. Others become more nocturnal, not because it's easier, but because it's the only time they're not exposed to rapidly shifting climates. Where the moon's loss unleashed devastation, time's passing replaces it with strange, unfamiliar order. The earth, too, begins to settle into new rhythms, not like before, never like before, but patterns nonetheless. Weather cycles change, ocean currents find new paths. Ecosystems, though fractured, begin to stitch themselves together in a new mosaic. Yet something remains missing, not biologically, not in the way scientists measure recovery through biodiversity or ecosystem resilience or carbon levels in the atmosphere, but something in the feel of the world. There is no longer a silver disk hanging quietly in the sky, no guide for dreamers, no mirror for poets, no companion for lovers whispering beneath the stars. The emotional tapestry of life, that invisible current that wove together humanity's earliest myths, rituals, and feelings of wonder, remains torn. Civilizations rebuild their calendars. Artificial lighting fills the night. Astronomy retools itself to focus outward toward planets and stars that never leave scars on our oceans or trace ripples across our shores. But the moon had been different. It wasn't just a light in the sky. It was a presence, a face, a force that for billions of years helped life bloom in the darkness. Even as Earth finds a kind of stability, even as species rise from extinction's edge and redefine what life can be without a lunar anchor, the planet feels lonelier. In the stillness of night, something once familiar is gone. Not just the tides or the eclipses or the gentle push and pull beneath the waves, but a companion, a silent, faithful partner that never once left Earth's side. And though life adapts, because it must, because that's what life does, it does so in a world forever changed, a world that remembers. The moon has never asked for applause. It doesn't blaze or thunder. It doesn't burn or shout. It simply lingers, quiet and constant, floating above our heads like a watchful eye, patient, pale, and always present. It's easy to forget it's even there, easy to overlook something so dependable. But maybe that's what makes it so special. The moon has shaped our nights and our nature, not with force, but with presence. From the earliest fires of humanity to the shining towers of modern cities, the moon has looked down on us through every stage of our becoming. Long before we built clocks, it measured time for us. Before telescopes, it stirred wonder. Before we wrote down history, it lit our stories and whispered them through shadows and tides. And if somehow it were to disappear, yes, life might go on. Maybe not immediately, not smoothly, and certainly not without loss. But over generations, we'd adapt. Some species would shift, others would vanish. New rhythms would emerge. Human civilization, though shaken, would try to fill the gaps the moon once held, with machines, with science, with stories we'd tell ourselves in the dark. But make no mistake, something precious would be gone. Not just a satellite, not just a source of tides or light or balance. The moon is Earth's silent guardian. It calms our spin, cools our chaos, gives beauty to our nights and meaning to our myths. It is a companion, not only to the planet, but to the soul. We could survive without it, perhaps, but the world would never feel the same. It would be lonelier, harder, emptier. The moon gives Earth more than mechanics. It gives us mood and magic. Can we survive a moonless world? Maybe, but should we ever have to? That's a different question, because wrapped inside this quiet exploration is a deeper truth, that we are surrounded every day by things we've grown used to, by wonders we no longer wonder about, by guardians we no longer see, the air that fills our lungs, the oceans that rise and fall, the forests that breathe with us, the sun that warms us, and the moon that simply shows up. So tonight, if your window opens to the sky, pause, look up, let your eyes find the moon, even if it's only a sliver or hidden behind clouds. Feel its calm. Let it remind you that something ancient and constant still watches over us, no matter how wild the world may seem. And if this story left a mark on your heart, if it made you think or slow down or see the moon a little differently than you did before, I'd love to hear from you. Tell me in the comments, what would you miss most if the moon were gone? The tides, the eclipses, or just knowing there's something out there, gently glowing in the dark? And if this peaceful journey through possibility made you curious for more, I invite you to stay. Subscribe to the Snoozy Scientist, where we drift through space and time together, one sleepy question at a time. There's so much more to explore, more mysteries, more wonders, more quiet moments that make you stop and say, I never thought of it that way. So thank you for watching, for wondering, for dreaming, and wherever you are tonight, under starlight or clouds, may you sleep gently with the moon watching over you, just as it always has.